In this video, we're going to look at the NPN bipolar junction transistor current source. And actually, the NPN bipolar junction transistor, when it sets a current, it actually sinks the current. As you can see, we got more positive up here, and then the current that we're going to set is along this path here. The transistor, and then this resistor sets the current based on the voltage across it. We consider current as moving in this direction. So we're actually sinking current from that side of the load to that side right there into the transistor. But the main thing is, we call current sources anything that sets a current source for the most part. So the main thing is though that whatever current we set with no load, that will be the current through a load. And the load can change. As long as we have enough power from the power supply, it will provide a steady current. We're going to use the 2N3904 in the TO92 package. Left pin, when you're looking at the flat sides, emitter, middle pin is base, and right pin is the collector. And you can see the pin layout there. We will turn the NPN bipolar junction transistor so that it lines up like that. And as a reminder, or if you didn't know already, you need a little bit of a base current to get a lot of collector to emitter current. That's how transistors work. We're going to have a resistor on the emitter side though. So whatever voltage we set here, we will lose about 0.6, 0.7 volts. But otherwise that voltage will be across the resistor, and it's going to let current through collector to emitter as needed to hold the voltage across that resistor. So we set the voltage, and then the resistor sets the current, minus about 0.6 or 0.7 volts. So for this video, I want an easy way to adjust the voltage. So we have a trimpot here. So it has a resistive element that goes, in this case, the top pin there and the bottom pin, from the positive power supply to the negative power supply. A resistive element along that path, this middle pin here, there is a wiper. It connects along there. So some of the resistance is on the positive side, some of it to the negative side, depending on where it is. You can go all the way to negative or all the way to positive. But in any case, you'll get a percentage of that voltage. And so we'll put that there. I have this jumper to go to the transistor base on the other side of the board right there. But otherwise, we can set the voltage. Now, as I said before, the pin layout here, left pin emitter, middle pin base, right pin collector for the 2N3904. If a transistor starts with 2N and it's a bipolar junction transistor, it probably has that pin layout. So all the ones that I've looked at so far do. So we'll just turn it that way. Now the pins are lined up like here, collector, base, emitter. So make sure we get the base to that jumper, the middle pin where the trimpot is. Now, what we're going to do is grab a 510 ohm resistor. And the nice thing about this one is we're not dealing with a lot of voltage, but up to potentially 9 volts. And so with the 500 ohm resistor, this is just a tad bit higher. So we're going to go to the negative rail right there. For every volt we put across the resistor, it's going to let through about 2 milliamps of current. So that'll go through the load, through the transistor, and through the resistor. We're just setting the voltage. If I set that to 5.6 volts, we'll have about 5 volts across the resistor, because you lose about 0.6 or 0.7 approximately volts. But in any case, about 5.6 volts there. We'll have about 5 volts across there. 500 ohms, it'll let about 10 milliamps of current through the load, the transistor, and the resistor. So now that we got that set up, we'll get our load. And our first load is just going to be a multimeter set to measure current. And so really the meter will not impact the current flowing through at all. And we set the current though, so it doesn't really matter. But the multimeter doesn't really have any resistance. Probably just a tiny bit, but for the most part no resistance. And so we can see the current that we set. So it's going to be in milliamps we'll set this to milliamps right there. And the power supply is on already, right there, 9 volts. And I have current limited to 20 milliamps right there. So that helps protect the multimeter in case we accidentally short to the power supply or something. But in case, no current's flowing right now because the circuit is not complete. And so we're going to take these alligator clips right there, and they got jumpers at the other end. I crimped them onto there. So put the red one to positive right there, and then the black one we're going to put to the collector. Let's zoom in a little bit, and so top pin up there for the transistor, and we'll zoom back, and we're going to clip those to the probes of the multimeter right there. So whatever current goes through the transistor and resistor will go through the multimeter. We will get the current on there. And there we go. We got about 8 milliamps of current. And the power supply there actually does say 8, so this is not as accurate as that one, but it doesn't do terribly bad. It's in the milliamp spot there. It's meant to measure, you know, amp range and stuff. But in any case, it's not doing too bad. You can see we got about the same number there. So we got that. Now, what we're going to do is, we got 7.99, move the jumper one spot. So now it's an open circuit right here. And we're going to take the LED there, put it to the jumper, and what you notice, we got the same current right there. Practically 8 milliamps of current. So the load changed, but it doesn't matter. We set the current. So now that we have that established, what we're going to do, we're going to zoom back here and take the multimeter out of the equation right there and replace the multimeter with the jumper, which is going to do the same thing. So you'll see we'll get back to 8 milliamps of current right there. We're going to take the multimeter and set it to measure voltage right there. I don't have to change anything because we got that spot. That plug just stays there unless we measure high current for this meter. Other meters are different. So in any case, we do have 8 milliamps of current. We're using a 500 ohm resistor to set the current. That tells me that across the resistor we have 4 volts. And I will look at that right there, 4 volts. And the trimpot, that means it's going to be set to about 4.6 or 4.7 volts right there. So there you go, 4.7 volts from a trimpot to a ground. Doesn't matter where we connect it to ground, it's the relationship to ground. We have the black jumper that connects the 2 negative rails together. And so we got 2 milliamps for each volt that we set with the 500 ohm resistor. What we can do is, actually I'll stay back, and I'm going to pluck the 500 ohm resistor and put a 1 kilo ohm resistor. It's actually 510 ohm. So this is a 1 kilo ohm, 1000 ohm resistor. Get it to the negative rail, and there you can see now we got 4 milliamps of current. Twice the resistance, half the current. Load doesn't matter. And so again, we'll see that we got the same voltage. The resistance doesn't really matter, and I'm sure you could push it to a point where it does, but for the most part you can use whatever resistance you want. But if it's a 1 kilo ohm, for each volt across it you'll have 1 milliamp of current. So 4 volts, 4 milliamps, and you got to remember you got the diode drop from base to emitter right there. So it's actually, you're setting about 4.7, and we can adjust that to whatever we want. So let's go back now, and we can't go too high. As I said before, that was one nice thing about the lower value resistor. So now I'm actually measuring the resistance of my body there. So we'll go down till it says about 2. And there we go. So we probably have pretty close to 2 volts. So again, that current meter on the power supply is not completely accurate. So about 1.631 it looks like. And we could measure the current to see it's probably 1.6 milliamps. So I got it to milliamps. We'll pluck that, and I'll go to the positive supply up here, and then the LED, and 1.6 right there. So if we bypass the LED, skip it, again, same current. So in any case, that's about it. And so I'll pop up some other videos. Make sure you check those out. Make sure you subscribe, click like, and the bell. There's a number of measurements and stuff you can take with this circuit, so it's pretty interesting. And I didn't show the schematic. I did at the beginning, but there we go. Instead of the current meter, we have an LED. We could also add the current meter on top of the LED. Doesn't matter. Whatever's in series, we could have more LEDs as long as we have enough voltage. They'll all have that same current. And so with the trimpot, though, you raise the voltage, that'll change the voltage of the trimpot, so you'll have to set it. But in any case, hope you enjoyed the video. Thanks for watching. I will see you in the next video.